This is Precalc Day 2 of 7.1. We have 3 different types of problems to do, or 2 different types of problems, but each one of these has an easier version and a harder version. So up here right now is I'm giving you 2 equations that are really close to what we call general form. Now I talked about yesterday, or the day before, that the general form is when you have all of the numbers FOILed out, set equal to 0. Everything's on one side. So if you look at our 2 equations here, they pretty much are in general form. If we were to subtract 7 from both sides, it'd be set equal to 0. Over here, we subtract 12x. It's set equal to 0. So what I want to do, though, is I want to take them from these forms and put them into their standard forms. When I say standard form, I'm not talking about y equals ax squared plus bx plus c form. I'm talking about, hey, let's put this into locus standard form. So that means it's either going to be an x squared equals 4py or a y squared equals 4px, right? So that's what we want to go for here. Now, there's another thing that you guys can do here. Now, because this one only has that x squared or 1 squared term, I can basically know this is what type of graph, or what the graph of this equation be. It's going to be a parabola. First of all, this section was about parabolas. But when I have an x squared and a y squared term, it could be a circle, it could be a hyperbola, and it could be an ellipse. Each one of those will have its own characteristics that I'll be able to look at the equation and decipher which one it is. But if it's just one term squared, we'll know. Now the first one here, I think, is the more simplified version. I don't have to do much other than a little bit of rearranging. If you remember on all of our formulas for our parabolas, it's always an x squared equals the p's and the y's, or the y squared equals the p's and the x's. Yes? That means x's go on one side, y's go on the other. Well, happens to be only kind of one of each here. But you also should recognize that since this is an x squared problem, it should really look like something like this. Which means the x squared has nothing with it. And that means I need to add 4y and subtract 3. And when I do that, I end up having a problem that's x squared equals 4y plus 4. Now, notice that according to this formula, this would be our very simplified, I'm not moving it left, right, up, or down. We also could translate this, right? Notice that this formula does not have stuff with y and then plus a constant. That means I need to roll all of this into one y with a constant. If you look at this, what can you do with that? I can take a 4 out. Look at that. You now know h and you know k. What's h?
1. It's negative 1.
Negative. H is 0. K is negative 1. The reason is because there is no h value. It's just x squared. It's supposed to be x minus h squared. And then it's y minus k. And it'd be a negative 1 to turn it positive. So I could find my vertex at 0, negative 1. Now this thing opens up for 2 reasons. Number 1, it's an x squared problem, so it should open up or down. Number 2, hey, wait a minute. I know that 4p has to equal the 4. So that means p is equal to 1. And since 1 is positive, it opens up. Which means that my focus should be directly 1 above the vertex, which then makes it 0, 0. Guess what? My line of symmetry runs through both the vertex and the focus, so therefore it is a vertical line of x equal 0. My directrix is a horizontal line because it's perpendicular to the line of symmetry, so it's y equals, and it's going to be 1 backwards from the vertex. So if I go 1 backwards, or 1 down, sorry, not backwards, but 1 down from -1, I'm at -2. You now have the 4 pieces of information that you would need to make a graph. Notice it says write the equation and then at the end graph it. After you identify all of those pieces. We just identified. We did that yesterday. I'm not going to go through that again. Watch that video if you want that information. The biggest caveat on all of this is that the distance from your focus to the curve and back to the directrix have to be the same. So therefore, make sure you are doing that. The next one. If you notice, it has a y squared and another y. So this one is going to open left or right. So we're going to have some issues. It means I still need to separate my x's from my y's, which means take 15, bring it over. Or from all else. So minus 15. Now this problem is going to be done 2 different ways. We'll get the same answer. I'm going to have to complete the square. And so I'm looking at all of these numbers. Wait a minute. A 3, a 6, a 12, and a 15. They're all divisible by 3. Because when I complete the square, guys, I want my a value on the quadratic to equal 1. And to do that, I get rid of the 3. And so I'm going to divide both sides by 3. This only works if everything is divisible by 3. If it doesn't, you have to use a different technique. So this becomes y squared plus 2y plus something equals 4x minus 5 plus something. Wait a minute, why do I put plus something? It's because if I add something on the left, I have to add something on the right. So right now, I've got it to the point where I'm actually going to be able to complete the square on the left. And to complete the square, I need to take 1/2 of b and square it. What's b? 2. Half of 2 is? So, remember, we leave it as 1 squared. On the left, but on the right, 1 squared is 1. The reason we left it in the parentheses is because that is the factor that goes into the square. So it becomes y plus 1 squared. Made it a heck of a lot easier. Equals 4x minus 4. Hey, wait a minute. Doesn't that look a lot like the problem we just had? And what did we do with the 4 last time? We took it out. We factored it out. So then becomes y plus 1 squared equals 4 times x minus 1. And now we can go through the whole entire process. What's p? P has to equal 1 because 4p equals 4. Where's your vertex on this one? It's 1, -1. Notice that x, or h and k are switched places. So be very careful on that. So we got a vertex, we got a p-value, means you can find the focus and you can find the directrix. This time, because p is positive, it's a y squared, it opens to the right. So it means when you go for their focus, you'll add 1 to the x value. when you're finding the directrix, it's going to be an x equals 0 because you're going to the left. Now, I did say we were going to do this problem twice. So I'm going to rewrite it here. And what if I said I couldn't divide both sides by 3? It's going to make things a little bit more interesting, but not necessarily any harder. I still need this number in front of y squared to be 1. So say that this number at the end was a 16 or a 17. It's obviously not divisible by 3. So maybe I'm not going to divide everything by 3. So instead, what I'll do, instead of dividing it out, I'm going to factor it out. So I'll put a 3 out front, and I have a y squared plus 2y plus something. And then that still equals, leaving the 3 intact on this side, I'm still going to add something to both sides. So now this part that's inside the parentheses that I factored the 3 out looks like we had over here. And half of 2 is 1, so I'm going to take 1 squared and add it to both sides. Wait a minute. What goes in the space on the very far right then? It's not 1 this time. It is a 3. Why? Because we took a 3 out over here, so guess what? This needs to be distributed back in. And so it'll be 3 times 1, which means I'm actually adding 3. And so when I do this, this becomes 3 times y plus 1 squared equals 12x minus 12. So you could take a 12 out. Good. So you still get the h and k. You still see that? It's x minus 1. It's y plus 1. But here's the thing. You go look back at any of the formulas for parabolas. Was there anything in front of the parentheses of x squared or y squared? No. So that means you got to go back and divide by 3 now. And now we have the exact same equation, the exact same focus, directrix, vertex, all of those things, line of symmetry, and now you can have it. If you remember, when you go to graph, it's the focus to the parabola and then to the directrix has the same distance. The next concept, guys, is to write the equation, and then obviously once you got an equation, you could graph it. Again, we'll skip it. But we want to build an equation. Given the fact that you're given a focus and a directrix, a focus and a vertex and a directrix, it doesn't matter. The key is to find a vertex for h and k and find p, because p is the key. Now, my suggestion to do these problems, make a very crude sketch of the information. It doesn't have to be perfect. I'm not even going to put tick marks down. That's a bad line. Okay. I'm just going to graph it. -6, 2. I think -6, 2 I could say is here, and that's my focus. I can then go -6, -1. Vertex. With just looking at that, you know it's going to open which way? Up. That tells us 2 pieces of information. That means we are going to be working with this guy. Right? An x squared problem. And p will be? It's opening up, so therefore positive. Okay? Wait a minute. H and K is the
vertex.
And we're given the vertex. So could you fill that in? So that means this is x plus 6.
Yeah, plus 6.
4 times something. We'll figure this out. And y?
Plus 1.
Plus 1.
Oh, yeah, plus 1.
Can everybody see that all I did was plug in h and k? I don't know p yet. Now, wait a minute. P is the distance between
F and
F and V, or the vertex to the focus and the vertex to the directrix. So now all you have to say is, hey, wait a minute, what is that distance? How far up did I go? 3. So guess what? I go plug 3 in here, and what's 4 times 3?
12.
So it's not so bad, right? It'd be no different if I gave you the vertex and the directrix. Or if I gave you the focus and the directrix, you know your vertex is directly in the middle. Okay, I'm not going to do the second example on there. I'm going to go to the third example. Part C. Part C is asking us to still write the equation and graph it eventually. And it wants us to say, hey, the focus is at -3, -4. We know it opens down, so that means it's an x squared where P is negative. But it also contains the point 5, -10 on the actual parabola, on the curve. So again, I'm just going to go straight to drawing something for this. -3, -4 is about there. 5, -10 is somewhere about there. And you know it opens down. So therefore, I don't know, something like this. That seemed kind of legit that it could possibly be there. Okay. Wait a minute. That means it must be what kind of problem again?
It has to be x plus h.
An x squared problem, right? Do I know anything off of here? Could I gather anything from this? It should be x plus 3. Why is it x plus 3?
Because its h value is the first one.
Right. Guys, the focus and the directrix have the same x value. So that means this line of symmetry includes a vertex. Which means it has to be at -3. So we know this is going to be x plus 3 squared equals 4 times something. Y minus something. I don't know those two. Man, I don't know. That's kind of interesting. Now we have to kind of dig a little bit deeper here. There's not enough information just to fill it in right now. We have to go into the formula, or not into the formula, into the definition some more. I do believe they say the locus definition states that the distance from a point to the focus, that distance is the same as what? Distance to the directrix, which we're going to say is back here, right? So, wait a minute. Do we have enough information to find any of that? Wait a minute. We got a points here. That's -3, -4, and 5, -10. Hey, all I have to use is the distance formula. Does anybody remember that distance formula? x2 minus x1 squared plus -1 squared. If I fill it in, now does it matter which one I call x1, y1?
No.
It doesn't, as long as I keep point 1 and point 2 consistent. 5 and -10 or 5 and 10 seem to be bigger numbers than 3 and 4, so I'll make that point 2. I'll lead with those. So that makes this 5 minus, or minus a negative, which is positive 3, right? Plus -10 minus a -6, or 4. So it's plus 4, and square that, which makes this 8 squared plus negative 6 squared. 64 plus 36 square root, which equals the square root of 100, which is 10. That means this is 10. That means this is also 10. How can I use that to help me find something? If I go 10 up from this point, where am I actually ending?
0.
At 0. That means the directrix is not up here, it's at 0.
Mm-hmm.
And what's so special about the directrix? It's the same distance away. Or the vertex is in the middle. So this graph is not very accurate. It's too far up. This is at negative 4 as a height, right? The directrix is actually at 0. So the middle between those two is, should be at negative 2.
So that's the vertex?
So it's negative 3, negative 2, which means, going back to my formula, it's plus 3. Or plus 2, sorry.
Plus 2, yeah.
Plus 2. Plus 2. Because it's y minus a negative 2. But wait a minute. P is that short little distance between those two. How far did I go in P? 2.
I just got it.
But it opens down, so it's not 2, it's
Negative.
negative 2.
So it'd be negative 8.
So it would be x plus 3 squared equals negative 8y plus 2, and you're done. Obviously, graph it with all the information that's truly there. Homework for day 2 is page 428, 21 through 24, 32 through 37. Have a great day.